Hello and welcome to another hypothesis test example. So in this example, a study was run to determine if less than 2% of pencils produced at a factory are flawed. A random sample of 1,000 pencils was found to have 15 which were flawed. Is there enough evidence at the 5% significance level to conclude that less than 2% of the pencils produced at the factory were flawed? So as usual, we need to first understand the question. So our research question, we're looking at, are less than 2% of the pencils produced in the factory flawed? So this is a yes or no research question. So we know we're looking at a hypothesis test. We're looking to conclude that less than 2% of pencils are flawed. So less than 2%, we're talking about percentage or proportion. And we're just looking at pencils produced at the factory. So we're just looking at one population. So we're doing a one proportion test. And our significance level is 5%. In addition to that, we have our random sample of 1,000 pencils, which had 15 flawed. So we have a random sample, and we drew from the whole population. We have a sample size of n equals 1,000. Our p-hat, we have 15 flawed out of our 1,000 pencils, otherwise known as 0.015. And then we also know that we're trying to show if p is less than 0.02. So from here, we need to state our hypotheses. So we have our null hypothesis and our alternative hypothesis. We have a hunch that it's less than 2% of the pencils are flawed. So our alternative hypothesis would be less than 2% of the pencils produced at the factory were flawed. For our null hypothesis, we take that statement and just switch it to equality. So 2% of the pencils produced at the factory were flawed. Putting this in symbol notation, we're talking about proportion. So we use P is equal to 0.022%. And our alternative hypothesis is that P is actually less than 0.02. From here, we have to justify that the study was well run and that we can run the test. So we need a good sampling technique. We have random and drew from the whole population. We need normality of the sampling distribution. So for the p-hat distribution, again, we need to look at n times p and n times 1 minus p. So our n is 1,000. P we are working with is our 0.02. So that's 20. And 1,000 times 1 minus 0.02 is 980. And both of these are Tenor mode. So we meet our requirement, giving a little more space. We have the study used a good sampling technique. And the conditions were met. The conditions for normality of the p-hat distribution were met. So we can run the hypothesis test. From here, we have to understand our sampling distribution. Again, we are looking at the p-hat distribution. We have n is 1,000. We are assuming p is 0.02 until we can argue otherwise. So for shape, we have normal. Again, see step 3. For center, mu sub p-hat is just p. So we have mu sub p-hat is 0.02. And for spread, sigma sub p-hat is the square root of p times 1 minus p divided by n. So we are looking at the square root of 0.02 times 1 minus 0.02, all divided by 1,000. And if we plug that into a calculator, we wind up getting approximately 0.0044. From here, we know our shape, center, and spread. Our job is to figure out the probability of getting a sample as extreme as ours and see if our sample is surprising. So we are looking at a normal distribution centered at 0.02. our sample was 0.015. Our HA, we have P is less than 0.02, so we shade left. So we're looking for that probability to the left. Again, this is our p-hat distribution. From here, we'll convert to z-score. So we need to figure out how our data value converts. So z, we will do our data value 0.015 minus the mean 0.02 divided by our standard deviation 0.0044, and we'll see what we get. And we get that z is about negative 1.13 or negative 1.14. So we have a z-score of negative 1.14. From here, we use our normal distribution calculator. In Canvas. So if we go over to that, putting in negative 1.14 for our z-score and hitting enter, we are looking at a left probability, which in this case is 0.1271. And we'll record that and then we'll switch back over. So we have a probability of 0.1271. We were looking at a significance level of 5%, I believe. Let's check. Yeah, so we were looking at a significance level of 5%. So that is our cutoff for what is deemed surprising. So this is otherwise known as 12.71%. It is not considered to be rare enough to be surprising. Right, so we have 12.71% is not less than 5%. Let's put a big X through that, so it's not less than 5%. So when we draw our conclusions in this case, we did not have something surprising if the null hypothesis were true. So this is not rare enough to be surprising if the null hypothesis were true, which means we don't have strong evidence against the null hypothesis. So for drawing our conclusions, we do not have enough evidence at the 5% significance level. To conclude that less than 2% of the pencils produced at the factory are flawed. So notice that I did not claim that there are 2% of the pencils are flawed. I just said that we don't have enough evidence to like strongly state that it is less than 2%. So hypothesis test conclusions are kind of like the supposed conclusions in the courtroom. So in our courtrooms, we're supposed to be innocent until proven guilty. So in this case, we kind of are forced to just assume the null hypothesis or let it stand. We're not proving the null hypothesis, we're just letting it stand, unless we can kind of prove the alternative hypothesis. So in the courtroom, someone can certainly be guilty of a crime, but not be convicted because there is not enough evidence. So it's possible that less than 2% of pencils are flawed, but we do not have enough evidence to strongly state that. So this is another example.